Hello, this is Mrs. Pullen for Algebra 2, Lesson 2.07. In this video, I'm going to go over how to solve radical equations when there are two radicals in them. So it's radical equations level 4. So we see that in example 5, that we have two radicals, and therefore we can isolate them. So what you do is you square both sides. So let's rewrite the equation so we can see what we're doing. And we're going to square both sides. So when we square both sides, we're taking that binomial and we're writing it twice, and then we're going to multiply it out. The left-hand side is a little bit easier. When you square a square root, the radicand comes out. You're really undoing the operation. And now we're going to double distribute. Now I'm going to write out an extra step so it's easier for you to follow. So we're going to take square root of 4x times square root of 4x. Then we're going to take square of 4x times 3. And then we're going to take 3 times square root of 4x. And then we're going to take 3 times 3. We're now going to simplify the right-hand side. So square root of 4x times square root of 4x is just 4x. What I had done in class the other day is the more technical way of doing it. When you're squaring two expressions with radicals, you're multiplying the outsides. In this case, they're just 1, so it's itself. 4x times 4x is 16x squared, and the square root of 16x squared is 4x. But we could have just simply multiplied it out right away. Now, when you're adding radicals, you treat the square root of 4x just like a plain variable, so you keep the variable and just add the coefficients. Just to make it more clear, if you had a rad b plus c rad b, these two radicals are the same, so you would just add the coefficients. So that's the rule, just in case you did not know that rule from Algebra 1. And then 3 times 3 is 9, and the right-hand side stays the same. We look to see if we can combine anything on the right-hand side, the left-hand side, but we can't. So what do we do now? And there's nothing on the right-hand side to combine. Well, we're now left in this step with only one radical. And I'll highlight that radical so it's easier for you to see. So there's only one radical. So how do you solve now? You isolate the radical. So I'm subtracting, hold on, let me get back to the pen. I'm subtracting 4x and subtracting 9 from both sides of the equation. This becomes 6 square root of 4x is equal 6x minus 4x is 2x. Negative 5 minus 9 is negative 14. So the next step is we want to square both sides. I'm just going to rewrite this a little further down so it's easier for you to see. So we're going to, I'm going to erase this. We're going to square both sides. Now, if I could, I would divide both sides by 6, and you can do that, but then you're going to end up with a fraction, and not that you can't work with fractions, but it's at least a little easier to do the following. You're not just squaring the 4x, you're squaring the 6. So 6 square root of 4x times 6 square root of 4x is 36. And if we were going to do it the technical way, square root of 16x squared, which is 36 times 4x, and 36 times 4x is 144x. So this is 100, or what we could have done is I could have just said 6 squared. This is another way of doing the same thing, times square root of 4x squared. And now we're going to multiply this out. So this became 36 times 4x if I did it the other way. And here, then this 36 times 4x would be 144x. So that's what we got here. And now we're going to expand this. So that's 4x squared minus 28x minus 28x. And negative 14 times negative 14 is 196. This becomes 4x squared minus 56x plus 196. So it's a lot of algebra. It's a level 4 problem. And now we have a quadratic equation. I know this because my term with the highest exponent is the 4x squared. And so it's a quadratic. So I need to get this in standard form by subtracting 144x from both sides of the equation. And you get 4x squared minus 200 plus 196 equals 0. Okay, so what do we do now? We are going to factor this. And although you could use the quadratic formula or completing the square, you want to see if it's factorable because it would shorten the problem. And it turns out that at least the ones in Delta Math, I lost my x here. They're all factorable. Now I'm dividing all terms on both sides of the equation by 4, and we get x squared minus 50x plus 49 equals 0. We're almost nearing the end. And now we look for two factors that multiply out to 49 and add to negative 50. And those factors are negative 49 and negative 1. And we get x minus 49 times x minus 1 equals 0. This becomes x is equal to 49 and x is equal to 1. And now we check. So I'm going to check in red, and we have to check both. You can use the calculator to check. You don't have to show it, but I'm showing it just for you to understand. So I'm substituting for 49 in. You could use GeoGebra for this. And we're going to multiply that out. 4 times 49 is 196. And the square root of 196 is 14 plus 3. And 6 times 49 is 294 minus 5 is square root of 289, which turns out to be 17. So we know the 49 works, and now we're going to try the 1. So we're going to check 1. So we substitute in 4 times 1 plus, well, the 3 is on the outside. So square root of 4 times 1 plus 3, is it equal to the square root of 6 times 1 minus 5? So that's the square root of 4, which is 2 plus 3. Is it equal to 1? And we see that it does not. So we're rejecting the 1. It's an extraneous root. And you should write down extraneous, the reason why you're rejecting it. So extraneous root. And so the final answer is simply just 49. I will make another video with the second number 6 from this worksheet on 2.07. But notice that these problems are long and you have to be very patient when you work through them. I hope this was helpful and I will see you on Monday.